Hello, how are you? Good, how are you? Thank you. Hi, good morning, how are you? Can you hear me clearly? Just want to make sure. Okay. Okay. Yes, Mubashir, yeah. Yeah, yeah. Okay. And I have 30 minutes, right? Sure. Okay. So I just yeah, sure. So just a quick, can I ask you a question before we begin? So yeah. So usually I reread the question, kind of collect my thoughts and I pace myself. Is that good? Okay. All right. Thank you. Thank you. Yeah. Thank you. And if you cannot hear me along the way, just let me know and I can. Yeah, for sure. Thank you. Yes. Okay, I'm just gonna read the question again. So thank you. So whenever I do my teaching practice, I always employ universal design for learning, and I always try to incorporate like various identities into it, and also I try to incorporate students' lived experiences into it to address these barriers. So one of the examples that I can discuss is I incorporated Indigenous, Black, African, Caribbean, racialized, and queer knowledge and experiences in my profession work through. I'll talk about one. Of course, I've taught physics before, so I'm going to talk about a physics example here. Through a grade 11 university physics, circular motion and gravitational unit, I always try to make the lesson very engaging. So the lesson was called Satellites, GPS, and Who Gets Access to Space Technology. So the purpose was for students to understand circular motion, centripetal force, orbital motion, gravitational force, speed, radius, and period, while also looking at who benefits from space technology and whose voices are often left out of physics and STEM in general. So before the lesson, I used student identity webs in class discussions to learn how students use satellite technology in daily life. Students mentioned GPS on the phone, Google Maps, weather apps, because it's a very fun topic. So I used those lived experiences to introduce the lesson because satellites were no longer just objects in space. I told them there's much more to it. They were connected to students' phones and communications. So basically, you're tracked, right? The main task was for students to analyze a teacher centered satellite data table. In the table, it included different satellite types, such as GPS, weather communication, and research satellites. Student looked at orbital radius, orbital period, speed, and purpose as well. They had to choose one satellite type and explain the circular motion involved, the identity and the centripetal force, and explain how gravity keeps the satellite in orbit. They also had to include a label diagram showing Earth, the satellite and orbital path, velocity, and the direction of the centripetal force. So I modeled one example first using a GPS satellite. I showed students how the satellite moves in a circular path around the Earth and explained that gravity acts as a centripetal force, basically, to keep it in. I modeled how to label the velocity tangent to the path and centripetal force towards the Earth. Then I showed students how to used the data table to explain why satellite motion depends on speed, radius, and gravitational force. So basically to integrate anti-oppressive teaching, I asked students to research one scientist, mathematician, engineer, astronaut, or advocate from a Black, Indigenous, African, Caribbean, racialized, or 2SL LGBTQ plus community connected to space, physics, maths, aerospace, or could be from technology. So examples came across, and they included people like Katherine Johnson, Mae Jemison, Mira Golda Ross, and Sally Wright, who were scientists, mathematicians, engineers, and astronauts from these communities, right? Students explained the person's connection and contribution and connected it to space, motion, tech, and also to STEM as well. For culturally relevant responsive pedagogy, I'm just going to use CRRP. We also discussed access and equity. So I asked students who benefits from GPS and satellite communication, who may be left behind when communication do not have strong internet, mapping access, or emergency communication systems. So this helps students connect physics to real world barriers. That's exactly what my goal always is, and this is exactly what I do, including rural communities, remote, indigenous, low income, and marginalized communities. So for UDL, Universal Design for Learning, I chunked the task, provided guiding questions, co-created success criteria, and allowed voice and choice. So student could use Google Slides, written response, label diagram, a poster, or a verbal conference with visuals. I used assessment data by circulating myself in the classroom, checking diagrams, listening to peer discussions, recording common errors such as confusing velocity direction with force direction. I paused the class and remodeled the satellite diagram when needed. So basically, students participated more because the lesson connected satellite motion to phones, GPS weather systems, and also representation of STEM. The student outcome was that students were able to explain circular motion more clearly using diagrams and satellite data in real life examples. And my reflection on the lesson is that it showed that the students are very engaging. We need to connect physics to lived experiences, equity, CRRP, UDL, identity webs, and real world technology. Sure, I'm going to read the question again. So, yeah, so when I introduce physics concepts, I always connect it to real world situation. And I always try to differentiate my lesson because if you don't, then the kids will be lost. So you always have to do these things because it becomes very, very important. So differentiation is very important. You have to differentiate your learners. You have to know where they are because if you don't, then they'll be lost, right? So, and also I employ universal design for learning whenever I teach physics, right, or any course. So a specific lesson that provided differentiation opportunities for our learners was from my grade 11 university physics course. It was from electricity and magnetism unit, but the focus was on magnetism and excuse me. So the focus was on magnetism and electromagnets, not circuits. So this live lesson was how do electromagnets show up in our daily lives? The student task was basically called Build and Test an Electromagnet. So before the lesson, I used student identity webs and class discussions to learn about the students' experiences with technology. I got to find out where students are at, right? Um, you guys can still hear me, right? Okay, perfect. And also, so basically, I did that. So students mentioned things like earbud speakers, phones, gaming controllers, electric motors, appliances, doorbells, transit systems, and MRI machines. I used those lived experiences to introduce the lesson because electromagnetism was connected to music, healthcare, transportation, gaming, and technology that students use every day. So I started by modeling a simple electromagnet made with a nail, a copper wire, and a battery. I showed students that when electric current flows through the wrapped wire, the nail behaves like a magnet. I asked students, where do you think this idea shows up in real life? So students connected it to speakers, motors, headphones, machines that use the magnetic force. So the main task was build and test an electromagnet. So that basically asked students to investigate how changing the number of wire coils affected the strength of an electromagnet. So students tested how many paper clips the electromagnet could pick up with different number of coils. They recorded their data in a table and used MS Excel to organize the results and look for patterns. Some students created a graph showing number of coils versus number of paper clips lifted. So for UDL and differentiation, I chunked the task into clear steps because I had some students that were struggling with physics. So I had one-on-one discussions with them, so I chunked the task into clear steps, build the electromagnet, test the number of coils, and recorded the paper clips lifted. We graphed a pattern, and I helped those students that were struggling with the graphing, and I showed them various examples of graphs on the board and explained the result, basically, right? And that really helped those learners that were struggling. I explained, and also I did pairings. So those kids that were struggling, I paired them with those kids that were not struggling. So I did a combination of that too, to make everything inclusive. I modeled the setup first. So I provided a data table, used visuals, allowed peer discussions, and gave students different ways to show learning. Some students explained orally during check-ins, while others used a written explanation, Excel graph or label diagram. So students who needed more support used a guided template, with stronger students explained why adding more coils increased the electromagnet magnet effect. The school resources I pulled on included department lab materials such as copper wire, nails, batteries, paper clips, and safety materials. I also used the Google Classroom because I'm a big advocate of technology to post instructions and examples, and I also use D2L as well. Uh, I used MS Excel for data organization and department support when setting up the lab materials. For students who needed extra support, I used the resource room to get the support, and also extra check-ins, peer support, additional time for those students that couldn't finish the activity on time. So what worked well was the hands-on part of the lesson. Students were engaged because they were building, testing, discussing, and seeing the results directly. The Excel graph also helped students see the pattern more clearly. What did not work at first was that some students rushed the setup and did not wrap the wire tightly around the nail. So their electromagnet did not work properly, so I had to help them with that. So, and also some students also forgot to control variables such as keeping the same battery and same type of nail. So I had to go back and help them with that, right? So what I learned was that I need to slow down the setup, model the wrapping more clearly, and show one proper trial before students started. I also learned that differentiation works best when the task is hands-on, chunked, visual, and connected to students' lived experiences. And this way, everyone enjoyed the lesson, and I was able to reach all learners, and everyone enjoyed this particular task. For sure. So a similar thing happened to me when I was at David Suzuki. I didn't teach the civics and careers course. So it was my first time teaching it actually. So I'm a very active, proactive, and resourceful individual. So what I did was I talked to the department head. So I set up a time with the department head and I got the resources. Plus, I did my own research. Plus, I looked at the ministry documents and I spent hours and hours and hours after the school was finished every every Friday and also Thursday as well after school. I stayed late in the school at David Suzuki to make sure that my lessons are ready and that my planning is ready and make sure that everything is ready, especially for the following week. So I looked at this curriculum documents. I looked at the overall expectations, specific expectations, to make sure that I'm prepared and also make it very engaging. So when I was, so in a case like this in history, well, first of all, I've done a lot of supply OT sections for history. So I'm pretty aware. Plus, I'm really passionate about history. Plus, I've done, I've, when I was teaching the civics and careers courses, I've taught civics twice, and we basically made history links to the civics part of the course at David Suzuki, and also at Chinguzi. I taught civics and careers as well. I'm always open to learning. And basically, how do I access and evaluate my resources? I also talk to my coworkers. I pulled upon my coworkers that were teaching those sections. I made myself available, and I was like politely, going after them and setting up sessions at lunchtime at the beginning to see what they're doing, because I wanted to follow exactly as to what they were doing and model it according to what they were doing, because I didn't want to invent a new wheel, because that's the last thing that you could do. And also, so my first lesson went pretty well, and also when they were watching specific videos on civics matters that relate to history, I made sure that the video resources were there. I made sure that the setup was there. I came early to the class to make sure that everything is set up properly. I always come to school very early. So at every LTO that I've done in the past, I always come. I'm very hardworking, and you can ask my references. I always come to school very early. I make sure everything is prepared. The videos are prepared that need to be watched. The setups are there. I make sure that everything is photocopied and digitized way ahead of time. I never rush the last minute. And if something does fail, I always rely on the tech support team at PDSB, and they're really great. I inputted support tickets, and I always do that. And I always try to improve my learning. And I also shadowed in my prep time. I also shadowed in my prep time that the teacher was doing, and I'm going to do the same thing during my prep time, if it's possible, to see how they were actually teaching a civics lesson, and which was connected to history, basically. So even though I didn't have the qualifications, I've done it before. You just need to be hardworking. You have to continue to improve, because this is your first time teaching it. So you have to be able to improve and model other people and talk to the department head, rely on resources, do your own research. Again, make sure that you're working in a collaborative team. I always reach out to my department head and also to those people who are teaching similar sections, because if you're not on the same page, things don't work. And I always try to have positive relationships. And I also invited, actually, that's the other part I wanted to include. I also invited, because one of the other teachers that was teaching that class, and I'll do the same thing in this LTO if I get it. I invited the other teacher into my class to see how I was actually delivering the lesson, how I was accessing technology, how I was talking about different points. And basically, the resources were evaluated because I was using those same resources that the other teachers were using, and I was cross checking it with the ministry documents. And I always reflected upon my practice. I always circulate myself, and I always ask the students as to how the lesson went, as to how things go, because I need that feedback. I don't sit. If you come to my class, I encourage you guys to come to my class. Do get this LTO, I never sit. I only sit when there's attendance to be taken or when I have to set up something. I always make sure that I circulate myself, and I took constant reflective feedback from kids. For kids that were bored, I made it very engaging for them by including very interesting videos on civics topics that relate to history and government. And included that on top of the resources that were there, because I didn't want those kids to be left out and to be bored. So this is what I always do, and I'm proud of it. I'm very hardworking, and even things that I haven't taught, like I gave examples of, I'm always willing to learn. Nowadays you've got Google, you've got technology, you've got your ministry documents, you've got your department heads, you've got your coworkers, and also talking to the admin doesn't hurt as well. So I always do that. I'm a very collaborative team worker, and I always pull on different resources and make sure that everything is prepared before the actual lesson is done, because that's the last thing you want to do, right? Yeah. I mean, I can add for sure. I speak four different languages. So I speak Pashto, I speak Hindi, I speak Urdu, and I speak Farsi. I understand a large part of Arabic too. I have worked in equity committee at Chinguzi Secondary School. I also worked at Safe Care and Inclusive Schools Committee at um, at at WRDSB. So when I was at Grand River Collegiate, I also worked with MSA teams all across. So because I identify myself as a Muslim, so I've helped kids that run MSA, and I've we talked about dismantling how we dismantle Islamophobia, and also how to cater to the greater community, and things of that nature. And I always make I always make sure that I contribute to the school beyond the curriculum and integrate myself beyond the curriculum. And I've done that before. So last semester at Chinguzi Secondary, as part of the equity committee, we talked about how to make education more equitable, how to make student voices heard, what steps we can actually we came up with various luncheon activities, right? To get the students engaged, like some samosa activities and things of that nature. It was really fun, and I enjoyed it. And I will continue to do the same. You always have to go above and beyond. I don't care like the length of the LTO. I just want to be known for my hard work and for my contributions. And I've done that before. I'm going to be willing to do the same if I get this job. Yeah. Yes, I've done that. Yes. Yes. Okay. Okay, sure. Just a quick question. In the form itself, it talked about the evaluation. So my evaluation was done at WRDSB, but I listed the references from PDSB. The last one's from Chinguzi. Yeah. Okay. All right. Okay. Yeah. You too. Thank you so much. Take care. Yeah. Thank you. Thanks. Yeah. Thanks. Yeah. Thanks. Bye. Thank you.